We are now going to see Holocene in some detail. Where is Holocene? It is a part of Neogene, Miocene, Pliocene, Pleistocene, and here is the Holocene, and it has got 5 stages. This Holocene, which is the topmost in the succession Holocene epoch, we will see now. The genus Homo first appeared and got diversified. Human beings belong to sapien species. There were other Homo genus also, for example, Homo erectus, Homo habilis. So, these Homo genus, they first appeared and they got diversified. There is a diluvial theory that there was a flood recorded in Bible and also in so many other religions in the world, amongst also the tribal communities, that says that there was a global flood, but later on we found that many of these deposits are glacial. They are not deposits that in water, they are the glacial, and additionally we understand the value of deep time. That means the world was not created few thousands or few lakhs of years, it was created billions of years back, and present is the key to the past. Principle of uniformitarianism we will discuss later, which says that the present day agents of erosion we see continued in the past and the time that was allowed was huge. So, therefore, in this deep time thick sedimentary pile was produced. So, the biblical flood, the diluvial theory talks about the Holocene huge extensive sedimentary deposits, and then subsequently we found that few of them are glacial deposits, and we explained their presence in terms of slow rate of erosion and then sedimentation elsewhere over a long time. The Holocene is well documented by the Greenland ice cores. We will see subsequently in the presentation from ice cores what kind of information the geochemist can gather. After the LGM, last glacial maximum, continental glaciers began to melt away. As I have told earlier, only the Arctic and Antarctic ice sheets persisted. Ocean level rose because the ice melted, so therefore the water level will rise, and it happened in the late Pleistocene and in the early Holocene. So, naturally the coastlines got shifted. 9,000 to 6,000 years ago is a warmer climate, and that climate persisted. This has to be recollected. The human invented agriculture. The oldest evidence of agriculture we found from the Zagros mountain, which is the border between Iran, Iraq and Turkey, almost 12,000 years back. Now, note that civilizations were probably connected in the ancient world as well. So, if one civilization has discovered agriculture, the other will come to know and they will also practice. With more research of the ancient world, this date might change. We may find older than the Zagros mountain spot where cultivation started. So, these things actually keep on changing little bit with time. One has to keep reading the literature for the latest update. Now, that the Holocene has been covered and is a quaternary time, I have shown the present day configuration. 21 kilo year, 1000 years back. So, it's almost like the nearly the present day situation of what? Paleogeography. We note that the Tethys Ocean has got vanished. What was earlier as the Tethys Ocean that got squeezed and that is not recognized as an ocean at present. Now, regarding the dates, a few things I want to inform you. Sometimes the radiometric dates by geochronologic dating techniques are calibrated to provide the calendar ages. So, cal BP means calibrated and BP means before present. Otherwise, uncal BP, here uncal means uncalibrated. Only BP can be ambiguous, but we do see use of BP in the literature. Why this radiometric dating gives only the geochronologic age, the reason takes an example of 14C. Here the dating gives the radiocarbon years, and this is because the 14C by 12C ratio has varied in the Earth atmosphere with time. We will see it in detail when we look at the geochronologic techniques. The uncalibrated age can be stated as 14CYA. So, the students need to remember the meaning of BP, the meaning of uncal BP, the meaning of cal BP, and the meaning of this kind of symbol 14CYA. This means is an uncalibrated age. That means this age cannot directly be linked with the calendar age. Some radiometric correction is required. Correction regarding the change in the past on 14C to 12C ratio. Now, here I am going to talk about very briefly about the ice core studies which has been conducted from Greenland and also from the Antarctic region. Air bubbles can be found within the ice cores, and they provide information of the CO2 and CH4 concentration in the past, not the present day air bubble. So, these are like paleo air, we can say paleo air bubble. So, studying these paleo air bubbles, we can have an idea in the past what was the atmospheric concentration of carbon dioxide, methane, etc. From these ice core studies, geologists have noted the signals. What is that? I am going to explain. Signals matching with the radioactive explosion. Radioactive explosions has happened in the past for experimental purpose and also in the real warfare, such as in the World War II in Nagasaki and Hiroshima. In these cases, the radioactive elements that got spread has also been well documented from the ice cores in terms of their anomalous concentration. So, it is very interesting and it is very sensitive way to know the Earth's recent past by studying the ice cores, and in particular by studying the air bubbles within them. And the late concentrations and their peaks also have been understood from the ice cores. I am talking over here the plate tectonic evolution, the life evolution, the chemical evolution. Some of these things will also come in subsequent lectures. The student might find interesting any part of the geological time scale, can get into the detail. Okay. Now, within the Holocene, within this Holocene, one portion I want to demonstrate in detail. So, here is the Quaternary, and within that there is Holocene. This Holocene has been divided into three parts. The bottommost is Greenlandian and the topmost is the Meghalayan. This Meghalayan age I want to discuss. Age is the smallest unit in the geological time scale. The Meghalayan age, which is also called stage in terms of chronostratigraphy, since Meghalaya is a state in India, and for the Indian students it is important to have little bit idea about the Meghalayan stage. It is an upper Holocene subseries. You see that Holocene is divided into three portions, and this is a upper Holocene subseries. Because age or stage has been divided, and here we are using the word subseries. What do we find here? The speleothem, the name is Km-A, in the Mamlu cave has been identified to indicate an interesting event 4.2 kilo year back. What is that? We have found brief but significant shift in del 18O values, and that event lasted for 2 to 3 centuries, 200 to 300 years. What happened that time? What do we interpret? That there is abrupt reduction in precipitation due to weakening of monsoon. Monsoon developed when the Himalaya raised to a certain height, and the cloud that was coming from the Arabian Sea and the Bay of Bengal, they started hitting the Himalaya. But 4.2 kilo year back is a time when the monsoon got weakened on the Indian land and also in the Southeast Asia. Possibly it was one of the reasons of the demise of the great civilization, the Harappan civilization, the Indus civilization. When I have referred the Meghalayan state, it is in the northeast portion of India, and when I have referred the Indus civilization, it covers mostly in Pakistan and also the western part of the Indian region. So, distance between The Indus civilization in the past and the Meghalaya state at this moment are more than 1000 kilometers. So, what was observed from the Meghalayan stage, the geologists have tried to link in the Indian plate, which can be far away. Now, interestingly, this was not a worldwide incident. This upper Holocene, what we are saying 4.2 kilo year back, it is not that worldwide there was decreased precipitation. For example, there are some places of the world where there is high precipitation, higher precipitation in this time, and cloudiness, these have been deciphered. The Meghalayan GSSP is the first one in the world to be defined on a speleothem. Just for our information, what is a speleothem? They are the secondary mineral depositions in the caves. Typically, they are the stalagmites, that means which are the secondary deposition growing upward from the cave floor. If it is growing downward from the cave roof, then we call it a stalactite. Now, these stalagmites developed in natural cave in karstic system, and it grows extremely slowly, very slowly. But note that if you are visiting some artificial tunnel, you will be able to see there are stalagmites developed. So, that is not a natural one, that is produced due to degradation of mortar in concrete lining, and here it is extremely fast growing 10 millimeter per year. So, in real time, in human perceived time, it grows significantly. Regarding speleothem, remember that 14C and del 34S and sulfate concentration can be deduced from the speleothem. Also, del 18O data can be decoded, and from del 18O we can understand about the air temperature and the humidity. Note that the speleothem geochemistry is generally insensitive to large increase in atmospheric CO2. So, the anthropogenic CO2 that got added and that got spiked up in last few tens of years is usually not reflected in the speleothem. Now, we are going to see an interesting term Anthropocene, and it is an informal term. It has not been added in the geological time scale. You will see Holocene, and then within the Holocene you will find the bottommost Greenlandian age, and the top is the Meghalayan age, is the youngest age in the earth history. But you do not see after Holocene Anthropocene written over here. Or if you look at the proper geological time scale, here you do not see Anthropocene. However, this term has become important. Holocene ended probably when industrial revolution started more than 100 years back in Europe, and that affected cycles of carbon, nitrogen, etc. significantly. We will see very briefly about it. The other view is that 1950 is a critical year where everything got spiked up, even tourism got spiked up, and many changes happened. We will see them, and it can be possibly the start of the Anthropocene. So, we can think like Holocene ended in 1950 onward Anthropocene started. It is important to designate Anthropocene. Why? Because it matters in other branches of science and other subjects, say life science, social science, humanities, arts, and even in international law. Let us look at a graph where year is plotted in this direction. This is 1900, this is 2000, and here the cumulative anthropogenic aluminium is plotted. Aluminium is there on the earth's crust, but in a concentrated form it is not there. Now, we find this is 1950, till 1950 aluminium use was there, but then over 1950 there is a drastic increase. Now, also look at the annual global plastic production. We can see not exactly 1950, but maybe we can say 1960 the plastic production increase. Now, in this graph year is plotted in this direction. This is 1925, this is 2015, and here the annual production of two things are plotted. The anthropogenic deposits amounts, all the man-made things has been plotted, and separately the concrete has also been plotted. Now, we see that progressively with time, not only there is an increase in the demand of anthropogenic materials and the concrete production, but they got spiked up basically. So, also in concrete over here we see that use of concrete has increased There has been an earlier suggestion of using the term human era, but then it was found to be misleading. There has been many major incidents in human civilization. If we take the mammal extinction in the late Pleistocene, which is 10,000 years back, this roughly matches with the time with the cultivation started. Should we take this as human era started 10,000 years back? These are not very important, and by recognizing human era, it will not much affect life science, social science, humanities, arts and international law in the way Anthropocene is defined with a approximate timing of 1950. Note that the term Anthropocene is not diachronous like the Iron Age. What is the meaning? The Stone Age, the Iron Age, the Bronze Age, etc. do not indicate coeval timing in different civilizations. It is not that so many thousand years back simultaneously the civilizations which were widely separated started using iron or bronze or copper or even stone or even the tools for their livelihood. So, once we say Iron Age or Stone Age or Bronze Age, we do not mean a particular time worldwide. So, therefore, these terms are diachronous, they are not time parallel. On the other hand, Anthropocene has been recognized as time parallel. 1950 we can pinpoint, this is approximately, there can be few years here and there, but in the geological time scale or of tens of years or hundreds of years, 2-3 years do not matter. So, the word Anthropocene series has also been used to mean a unit of strata, the real rock 1950 onwards, whatever got deposited, whatever sediments got deposited, we may call it as Anthropocene series. How many novel anthropogenic or man-made minerals we can think? It is surprising to note that the number is such huge, such a large number, 2, 1, 2, 3, 4, 5. So, 2 lakh, and this is more than an order of magnitude of the number of natural minerals. So, at present if we look at the number of natural minerals on the earth and the artificial materials that have been created by human beings, the latter has significantly outnumbered natural minerals. The carbon isotope anomaly has been noted in the anthropogenic sediment, and note that such equivalent anomalies in the geological past as well. In the Carboniferous time, there has been coalification at several places in the world. The deposition and preservation of carbon material was tremendous. So, while we note the carbon isotope anomaly or carbon anomaly in the Anthropocene sediments, it does not mean it only happened in the past by the human beings. Long back nature has also done carbon anomaly. Ceramics came into the geological history from the latest Pleistocene, from the old civilizations. Artificial radionuclides, their testing and their application in the world war. Concrete, this is very, very important. So, I have kept in a bold, and plastic, these are the two widely accepted anthropogenic material that can define the Anthropocene time. Fly ash, glass microbeads, polycyclic aromatic hydrocarbons PAH, the artificial ground or urban strata, the pitch with which we make the road, tungsten carbide even in the ballpoint pen in our day to day use, synthetic garnets in the lasers, the mineraloids, plastic. Note that plastic is better preserved in deep oceans in a cold environment and with the lack of UV light. So, in the deep ocean there is a good chance of preservation. Plastic is not only there on the land portions, but the plastic which we discard, if not properly collected, it can go to the rivers and then it goes to the seas and it affects the marine ecology. The Portland cement, the alloys, technological crystals used in some semiconductors, not getting into their detail, the electronic applications, tools that have been used in the ancient time and also in the present day tool, for example, iPhone or other kinds of phones. These materials have been fashionably called as technofossils. Just as fossils indicate in a vertical column how the organism has evolved, if we look at the mobile phones, with time its complexity has increased. So, certain mobile phones can now indicate certain time range in the recent past. So, in that way iPhone or other mobile phones can be called as the technofossils, and there are other technofossils as well. Now, are there organisms that can be marker of Anthropocene? The organisms have been used, the fossils have been identified in great details to understand the geological time. In the very recent time, yes. For example, the zebra mussel, native of the Caspian Sea and the Black Sea, was transported to North America as the ships move, and presently they dominate across half of the continent. But then later Asian clam became more significant anthropogenic indicator. So, yes, the organisms can also indicate, with new geographic mixing and attaining the worldwide occurrences, they can also indicate time at present, and also maybe in the future the geologists will be able to locate the time horizons based on them. That modern human activities, the technological activities, are triggering mass extinction that will rival any of those happened naturally in the last 600 million years. We said end Permian is a time of most catastrophic mass extinction, but already what is happening on the world, rate of extinction may be may reach to several hundred species per day that might go extinct in next 20 to 30 years. Tropical species are more vulnerable, it is important, and we need to preserve them. If one species get extinct, then the other species which were dependent on those species either through food chain or by other means will also move towards extinction. This is important. So, many tropical reefs at present are endangered due to overfishing and contamination in the sea water. Plastic as an anthropogenic marker, this looks something new to the geoscience students, and in the textbooks of stratigraphy this issue might not be available. A new kind of material assemblage has been described as plastiglomerate, and whether to call it a rock or not is debated. What is a plastiglomerate? It is the rock fragments, the plastic debris and the organic materials. What are the organic materials? It can be shells, wood and or coral debris which are held together in a matrix of once molten plastic. It can be found in the seashores, and there has also been record of plastiglomerate from the shallow and the deep sea. The word plastiglomerate reminds us the well known rock conglomerate. Why we doubt to call plastiglomerate as a rock? There is a question. Some researchers calling it plastiglomerate as a rock, some are calling just as an assemblage. The point is that to call a rock, all its components should be natural. Plastic is artificial, or artificial. So, that is why once some rock fragments, plastic debris or organic materials are held together by once molten plastic, geoscientists doubt whether to call plastiglomerate as a rock or not, but loosely speaking we can call it as a rock. We can call it as a rock. Plastiglomerate can be buried, can be preserved in the rock record. So, in future, not at present, maybe after thousands of years, we call it typically as a marker. Note that plastiglomerate is more resistant than pure plastic or only plastic. So, its chance of preservation in the rock record is high. High potential to get preserved in rock record. Let us have a look at different plastiglomerate photographs. In this case, the plastic matrix has been identified, corals make one of the components. Amygdules have also been identified. Out of these three, plastic matrix is the artificial input within this rock. Now, in other examples, we can see a rope, and here also a rope is visible. Now, once we look at the definition of plastic glomerate, which was presented here, we should also be lenient if the plastic debris and organic material are only found, we can also call it a plastic glomerate. My point is, plastic plus any natural abiotic material should loosely be called as a plastic glomerate. This can be the most generalized definition. Now, there are certain other terms which we have to know. Pyroplastic is a large plastic components which is less dense than the plastic glomerate, of course. And plastic rusts, here is a coating of plastic formed by the wave action. Suppose there are rocks in the shore area, then plastic which came through some river might coat the rock, might surround the rock. So, here the word crust means that's which surrounds. So, what surrounds? It is the plastic. And what is the microplastic? It is a kind of plastic with size less than 5 millimeter. This is a photograph of plastic materials found within the soil horizon. This is absolutely common, not just from some one country. We can draw a line over here, and we see that this line is a bit curved. So, this we are calling as the plastic horizon. The question is how long these plastic horizons have been documented. What is the maximum length which has been documented in the literature? Students can search. These plastic horizons will be more common near the dump site, waste dump sites, which are located usually outside the city. Now, let us look at the distribution of microplastics in the marine sediments, and we find so many locations worldwide. That is the west coast of India, where I am putting this arrow here, and then at so many places, which means that plastic pollution and distribution of microplastic in marine sediment has become a global observation or global occurrence. One may ask a question, if I look at this plastic horizon, here the thickness is more and here the thickness is less. Yes, the observation is genuine, and if you put a question, this indicates how many years. We do not have a clear-cut answer as yet. This can indicate, I am putting approximately say 2 years.